So today I'll be showing you how to put your equation into your calculator and graph it. So with your equation, you have 3x to the fourth plus 2x cubed minus 9x squared plus 4. First, you're going to want to hit the y equals button and clear out if you have anything in there. And then put your equation in. So you have 3x, and how you do to the fourth, if you hit the little caret button and then the fourth, and then plus 2x, and then the caret button again to the third, and then minus 9x, and then there's actually a squared button right here that you can hit, and then plus 4. And then all you have to do is hit graph, and it'll graph the equation for you. Today I'll be talking about identifying 6 easy things in a polynomial. The first thing is degree. And you look at your equation, in this case it's 3x to the fourth plus 2x cubed minus 9x squared plus 4, and you look for the highest exponent. In this case it would be 4, and that's your degree. Then I'll be talking about end behavior. The end behavior has to deal with the highest exponent again, and you look at the number in front. If it is a positive or negative, and in this case it's a positive. And then you go to the exponent and see if it's even or odd. In this case it's an even. So then you go to the graph or the chart that you can make, and you see that positive and even equals up and up. And then here's all the other options on here. The next thing is turning points. Then again, you look at the equation just like this. You look at the highest exponent and you subtract 1 from it. So from this it'd be 4, and then there'd be 3. So there'd be 3 turning points. So you just subtract 1 from the highest degree. The next thing I'll be talking about is zeros. So first you just have to factor out your equation and then say that your factors are x minus 3 and x plus 2. All you have to do is set them equal to 0, so x minus 3 equals 0, and then x plus 2 equals 0. On the 3 side, add 3 to each side, and you'll get 3. On the 2 side, subtract 2 from each side, and you'll get negative 2, and that's how you find your zeros. The next I'll be talking about if you have a multiplicity of zeros, which is basically where your factors are the same. And you'll do the same exact thing, so for each of them, you'll add 1 to each side, and you'll get x equals 1. You can either write this as x equals 1 and x equals 1, or you can write it as x equals 1 multiplicity of 2. The last thing I'll be talking about is relative maximum and relative minimum. So you look at your graph that you make on your calculator like I showed you earlier. And obviously it's going to go on forever positive and forever negative. But you look for your lowest turning point, which would be your relative minimum, and then you look for your highest turning point, which would be your relative maximum, and that's how you identify all those things.
My name is Evan Brown, and today I'm going to talk to you about how to solve an equation with factoring. When you factor, you break down an equation to find out the factors, which means what multiplies back into the equation to equal 0. So we have the equation x cubed plus 4x squared equals 12x. So first off, it's not equal to 0, so we're going to have to make it equal to 0 by subtracting 12x from both sides. So now our new equation is x cubed plus 4x squared minus 12x equals 0. Now, when you look at this equation, you can see that they all have something in common. They all have an x, so you can factor out the x by putting it outside of the parentheses. So now your equation is x parenthesis x squared plus 4x minus 12 equals 0. Now, to find the factors of this new equation, you have to figure out what adds up to get 4 but multiplies to get negative 12. So as you can see, 6 and negative 2 add up to get 4 and multiply out to get negative 12. So now you have x parentheses x plus 6 parentheses x minus 2. So those are your factors. But now to solve the equation, you have to equal out each one of those factors to 0. So you have x equals 0, and that's simple enough. That's how to solve that right there. So you know 0, you can plug back in up here, and it'll equal to 0. Then you have to do x plus 6, and to get it equal to 0, you have to subtract 6 from both sides. So now the answer is x minus 6. And you can plug that back in the equation and it will equal out to 0. Now you have x minus 2 equals 0, so you'll obviously have to add 2 to both sides and you'll get x equals 2, which again, you can plug back into the equation and it will equal out to 0. So that is how to solve x cubed plus 4x squared equals 12x through factoring.
Alright, so today I'm going to be showing you how to divide the polynomial x cubed plus 7x squared plus 15x plus 9 by x plus 1 using long division. So first what you're going to want to do is figure out what you multiply x by to get x cubed, and that would be x squared. So we write x squared, and then we multiply x squared by x. We subtract x cubed, and then we multiply the plus 1 by x squared to get plus x squared. And then, like normal long division, we're just going to subtract the like terms. And so the x cubes will cancel out, and that will leave us with 6x squared. And then you just repeat the process after you bring down the next term in the dividend, which is 15x. So we bring down the 15x and figure out what we multiply x by to get 6x squared, and that would be plus 6x. So 6x times x would be 6x squared, and then plus 1 times 6x would be 6x. And then just subtract like terms again, and the 6x squareds cancel out, and we're left with 9x plus 9. And then from there, you multiply x by 9 to get 9x, so plus 9, and then 1 times 9 would also be 9. We subtract 9x plus 9, and we are left with a remainder of 0. And so the answer would be x squared plus 6x plus 9. And next, getting into the remainder theorem, if you really don't care about the answer, you just want to know what the remainder would be, you basically look at the divisor and x plus 1. And so if we set that up in an equation, it would be x plus 1 is equal to 0. And then if we solve for x, we subtract 1 from both sides. X is equal to negative 1. And then we basically just plug the negative 1 in for x in the original dividend and solve from there to figure out the remainder. And so negative 1 cubed plus 7 negative 1 squared plus 15 times negative 1 plus 9 is equal to negative 1 plus 7 minus 15 plus 9. And so the final answer would be 0. And that's how you basically use the remainder theorem to figure out the remainder of a certain polynomial. Next, getting into synthetic division. If we want to divide the same polynomial using synthetic division, we would set it up like this, and we use that x plus 1 to find that x is equal to negative 1, and these are all the terms from, or the coefficients from the original dividend. And so I'll be the 1x cubed plus 7x squared plus 15x and plus 9, and we bring the 1 down to start. And negative 1 times 1 would be negative 1, and then we combine the 7 and the negative 1 to get 6. And then we would just basically continue on by multiplying the negative 1 by the 6, putting it right there, combining like terms, and repeating the process until there's no more coefficients left to use. So negative 1 times 6 would be negative 6. 15 minus 6 would be 9. Negative 1 times 9 would be negative 9. 9 minus 9 is equal to 0. And we find that our remainder is 0. And yeah, and then we use these three numbers, we put them back into the original polynomial, but we use one term are 1 degree less than the original polynomial. So since the original polynomial started with x cubed, the answer would be start with this number combined with x squared. So 1 is the coefficient of x squared, so it would be 1x squared plus 6x plus 9. And that would be the final answer. That would be the answer to x cubed plus 7x squared plus 15x plus 9 divided by x plus 1. Tom Brady's 41 and he has 6 rings. So now I'm going to be discussing the fundamental theorem of algebra. And basically the fundamental theorem of algebra is based on the degree of a polynomial. That is how many roots the polynomial graph will have. For example, let's say we have like any second degree polynomial right here. As you can see, it has 2 real roots. And for this third degree polynomial, it has 3 real roots. Now, this does not always occur because you've probably seen sometimes polynomial graphs that look like this, where not all of the roots are real and not all of them cross over the x-axis. And so these roots are called complex roots. And basically, they are just non-real roots that never cross over the x-axis. And you may be wondering if like a third degree polynomial could have 3 non-real roots, and they actually cannot, because non-real roots always have to come in pairs. So it would be possible for a second degree polynomial to have 2 non-real roots because they come in pairs, but it would be impossible for a third degree polynomial to have 3. So for example, you've probably seen a polynomial something like that, where there are no real roots touching the x-axis. And yeah, that is the fundamental theorem of algebra.
Hello, my name is Evan Brown, and I'm going to teach you how to factor out to find all the zeros using rational root theorem. So basically, rational root theorem is when you look at an equation and take the constant over the leading coefficient to find out all of the possible roots of the equation. So like so, in the equation, x to the 4th power minus 4x cubed minus 16x squared plus 21x plus 18 equals p of x. So I took all of the factors of 18 over 1, because that's the only factor, and 1. So you get 1, 2, 3, 6, 9, and 18 are all the factors of 18. So then you have to do plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Because when you do all the fractions, you have to do plus or minus for each. So then, once you figure out all of these, you have to plug each one of them, plus 1 and minus 1, for every single one of them, in synthetic division to figure out if it equals 0. So I plugged each and every one into synthetic division, like so on this piece of paper, and I figured out that the only 2 roots that equal out to 0 are -3 and 6. So for example, -3 when plugged into synthetic division equals out to 0. So now that you have x to the 3rd power minus 7x squared plus 5x plus 6, that's your new equation. So then you have to plug the other factor into your new equation using synthetic division again to equal out to 0. So now your new factors are x plus 3 because x equals -3, and x minus 6 because x equals 6, and also x squared minus 1x minus 1, like so. So now you have your new factors, and to figure out the 2 factors in here, you have to use the quadratic equation. So you do -b, which is 1, plus or minus the square root of b squared, which is 1, minus 4ac. So then that's 4 times 1, which is 4, times a -1, which is -4. So it would be 1 minus a negative 4, which is equal to 1 plus 4, all over 2a, which is 2. So now your new quadratic equation is 1 plus or minus the square root of 5 over 2. So now when you factor all of that out, you get your zeros to be x equals negative 3, x equals 6, x equals 1 minus the square root of 5 over 2, and x equals 1 plus the square root of 5 over 2. And now to check all of these, you just plug it right back into the equation. And the reason I got 4 answers and 4 zeros is because the leading coefficient is raised to the power of 4, which means you will have 4 factors that equal out to 0. So that is how to find all zeros using the rational root theorem.